Hope all are able to see my screen. Just confirm once. I am on the Word document.
Yes, sir. It's
Yeah,
visible.
the topic where we left yesterday, right? We are on that topic, internal working of Python. So just one more minute, then we will start. Okay. So today's discussion will be continuation of yesterday. Yesterday we have seen, right? What is Python? How to install? What is an interpreter of Python? How the code gets executed on Windows command line. Okay. Now today we will see a little bit of internals of Python, a little bit of theory, but very important technical concepts which might be asked in interviews. Okay, so just a recap of a couple of things which you already know. I would like to start our discussion today from this topic. Okay, we'll just revisit this topic. Okay, hope still my screen is visible. Okay, let us start our discussion on topic called what are bits and bytes. Just a quick recap. We all are well aware of all these things. That's what I believe. That's what we already studied in our academics, right? But just to recap once again, because as part of Python, what we are learning, so there is a necessity of just revising these topics as well. And there is a little important concept that I will show you why we are just revising this part. Okay, and from there we will take it further. So all good to start. Okay, yeah. So first we'll understand what is a bit, what is a byte. We all know. Okay, there is a small table that I'm sharing here. Okay, we all know everything. 1 byte equals 8 bits. Okay, and from there all those units are defined. What is KB, MB, and all that. Okay, I just don't want to discuss all those. You all know very well. What my interest is, I'll just quickly drive you through this part. Okay, we will discuss what is a bit. Today's section will be mostly theory, but very important because I am covering technical aspects of this theory. Okay, just try to focus. You also try to read accordingly as I'm sharing the screen. Okay, and I will explain you one by one all the concepts. Okay, and we will take a pause whenever you have a question. Please ask questions if you have any. Okay, right. So let's start. So we all know what is a bit. A bit is a single binary digit. That is the most basic unit of the data. This is the core fundamentals of how the actual processing happens on the processor level, right? All the data, all the information, all our code will be converted ultimately into bits and bytes, okay, in the form of zeros and ones. What are zeros and ones? Zeros and ones are nothing but the electronic signals, okay, that will either show on or off. And the primary measuring the data transfer rates, everything as per the units we know. Okay, what is 1 MB, what is 1 GB? Actually, these are the bits are used in calculating our data. Okay, the transfer of data, what is the network speed and all, we'll calculate in terms of bits and bytes. For example, we have our home internet, right? What we'll ask that guy whenever we are trying to get the connection, we'll inquire first important thing is what is the speed of the internet. Okay, how much speed he is providing for that particular plan. So the units or the measurement what we are asking is in terms of kbps or mbps. Okay, so that is what is a bit, a least unit of our data on the processor. It could be a 0 or a 1. Then I am not sure whether you still remember what is a nibble here. Okay, so the nibble is nothing but a group of 4 consecutive bits. So generally 1 byte is nothing but 8 bits, right? So half of the byte is called as a nibble, a group of 4 consecutive bits, half of the bytes. Okay, and byte is used for, nibble is used to represent particularly the hexadecimal digit values. Okay, the hexadecimal digit values are nothing but starting from 0 till F. Okay, that is 16 in the hexadecimal form. So particularly to refer this 0 to F, which is nothing but 0 to 16 in hexadecimal, internally a nibble will be used. And nibble is nothing but a half byte. That means 4 bits. Okay, as simple as that. Next is, yeah, the main unit, byte. Okay, this is all we mostly talk about in terms of bytes. Bytes are nothing but a sequence of 8 bits grouped together. And bytes can be, represented in 256 different values. This is very important. We will discuss on this. Okay. For every single character, like whatever 256 characters what we have on the system today. Okay. All this will be individually represented by the 2 power 8. Okay. In the form of byte. And this will be used to, measure the size in megabytes and gigabytes. All our storage, everything will talk in terms of bytes, right? And the symbol here to refer bytes is capital B. For bits, we will use a small b. Okay, in terms of when we write literals, right? We'll write small kbps. When in terms of bytes, we will write it in capital B. Okay, that is the main difference here. This looks very simple. Okay, guys who are getting ready for a job profile and you are looking who are looking for to get into a new job very soon. I have just one update on you for on this particular thing. Okay, I have included these things for a particular reason. Okay, so I'll just update you within a minute what is happening latest in the industry. So when we are trying to apply for a job, right, especially Raghu and Ramakrishna, okay, if you observe or if you are trying to look into any of the websites. So nowadays, what is happening is when you are trying to update your resume on the job profiles, we are getting a certain auto options. Okay, so whenever you are applying for a job, okay, Naukri or Indeed or whatever, what is happening is automatically we are getting options, for filling up certain information on your profile. Okay, for example, uh, you are trying to apply for a data analyst job. Okay, as soon as you click the requirement of the job and you want to upload your profile, right? So automatically Naukri or Indeed, what they are doing is they are giving you few more options to fill for your profile. For example, in the very first option, what it is asking is whether you know Python. Okay, then you will type yes. Then the next question, what it will ask is, are you aware of machine learning algorithms? Then you say yes. Then third option, it will ask whether you are aware of AI concepts. Then you say yes. Okay. So what is happening in this process is earlier what you used to do, you used to directly submit your resume on the job profiles. And those resumes will used to pick by the recruiters, the HRs. Okay. And they used to screen your resume and depending on the requirement and if your resume matches, okay, you might be getting a call. Now, what is happening is this is what we discussed in very first demo because of the AI. Okay, so AI is already started its role. Okay, in filtering the resume itself, the very first step. Okay, this is the very real time happening that I learned recently. Of course, our company is not yet implemented these things, but other companies are already started. Okay, so what is happening is on the very first step itself, the agent sitting locally on your that website, right? It is filtering depending on what you are giving there on those options and what you have in your resume. Okay, finally, after filling everything, okay, the agent is checking that whether you are eligible for that position or not immediately. After you fill everything and you submit, right? It is happily saying you are not at mark to this position. Kindly try next time. You see the criticality of, even now you cannot directly post for any requirement also. For the very first step, your resume is getting screened by an agentic AI or a agent chatbot sitting locally on the website. Okay. Why I'm telling this story is the actual second part. Okay. Now, what I recently came to know is what I have seen for one of my colleague is after this first filtering, okay, which is done by AI. Fortunately, if your resume gets picked up, you are getting a call. The first screening is happening from the recruiting HR. He will just casually look into your profile and discuss what all you know. Then what is happening is you are getting a call for an interview. And I'm surprising to see that the interview is getting taken again by an agentic bot. Ramakrishna Raghu, this is specially for you. Okay, I'm sharing this latest trend happening for the new guys who are looking for the jobs. So your first interview will be with AI agents. Your first interview will be with AI agents. Okay, very important thing. So why I'm telling this is I'm seeing a criticality there. Okay, I'm seeing how how much filtering can happen for a particular job in coming days. Okay, so first round resumes are getting filtered on website itself. Okay, on portal. Second, first round is with AI agent. You know what is happening in AI agent? Okay, how it works. I'll tell you just on the high level. This AI agent, assume that you are giving an interview on just Python. Okay, just assume that you just went for a Python job. Okay, a Python profile. So this agent, what it will do is it will be trained on 1,000 questions of Python. Guys, this is fact. Okay, this is happening. It started. Okay, so just try to see the severity. Okay, so this AI agent will be trained with 1,000 questions on Python. So obviously, we human beings cannot answer all these 1,000 questions. Okay, but for your interview, assume that interview is scheduled for 1 hour and you are supposed to answer 50 questions. Your first round. So what is happening is out of these 1,000 questions, AI will keep you any question randomly. You got this? So this is what is the severity of interviews nowadays. So why I'm bringing this point here is one of the question was syntax on Python, obviously. Okay, one of the question was the agent has given a code and it asked to find the syntax error. This is a very simple question, right? So this is how the agents are taking the first round of interview. And one of the question out of this 50 is whether Python is a, it has given 4 options. Okay, one of the option is interpreter. Okay, so basically the question is Python is which kind of language? It has 4 options. One of the option was interpreter. So the right answer is interpreter. Okay. One more beauty is the more you answer correctly, the more you answer correctly, the more tougher questions you will get. The more tougher questions, I should not use word tougher, I should say more in-depth questions. Okay. Raghu and Ramakrishna, I want to listen your comments on this. Okay, I'm telling this because we are at the very beginning, of starting our course and learning, right? So, fortunately or unfortunately, this is the pattern now started in the industry. Okay, because there are a lot of competition happening for the same positions. So HRs and managers thought not to take the headache. They simply got AI into picture. Okay. So first step, AI is screening your profile. Second step, your first interview will be with AI agent. So you have to keep the headphones to your ears. Questions will come up and you have to listen to the question. If there is a typing option, you are typing the answers there. If there is a speaking option, okay, even agent wants to hear from you. Okay, it might, it's a kind of, directly face to face. Okay, it will behave like a person is sitting opposite you for an interview. So there is also possibilities that it expects you to speak depending on one scenario. Okay, it will give one scenario. It will ask, in this scenario, how you will resolve this problem. Okay, so this is the kind of interviews now already started in the market. Okay, so my humble request is we have to be very, very, learn very seriously, and whatever we are learning, please grasp it, keep it in the context, and try to practice. Okay, as as we are proceeding. So this is what the important thing which I want to update here. Now, why I just remembered this is we are talking about very basic things, right? What is a bit, what is a byte, and a nibble. We never know, your first round interview might get this kind of question also. Okay, so that is the reason I just wanted to keep these things as part of our discussion. Okay, so just try to understand and recollect and take this opportunity to revise. If we know, just take an opportunity to revise these things. Okay, right. So we understood what is a bit, what is a nibble, and what is a byte. So ultimately, what is happening? Okay, ultimately, when we talk in terms of bits and bytes, right? What is happening? How actually our data or code, getting executed on the machine, on the processor internally. For example, I'll take, suppose I want to store this number internally. Okay, 24. It's a numeric value, right? So how it will get processed or stored in our system internally? Obviously, in the form of zeros and ones. But how actually that we are getting? Just try to recollect what is happening. Okay, so because these are binary, all are binary digits, zeros and ones. The concept here is this number will get divided into two. If you all remember, okay, we have understood or learned already what are binary systems, right? So if we divide it 24 by 2, how much we'll get? 12. What is the remainder here? 0. Okay. Try to understand the concept. Okay. This is very, very important. What is happening, you should understand. 12 divided by 2. 12 6, 2 6 are 12. Remainder is 0. Then 2 3 are 6. Remainder is 0. Then 2 1s are 2. Remainder is 1. So now to represent this 24 internally, obviously, how we'll write? We'll write in the binary format. What is the binary format of 24? That is reverse from bottom. 1, 1, 0, 0, 0. Now every number, okay, will be in 8 bytes. Okay. So we got 5, 5 bytes here, right? So what we'll do, we'll add rest of the 3 bytes to complete. Sorry, we got 5 bits. We will complete the byte adding 3 different bits to it. Okay, which will be all zeros, obviously. So how we converted this? Because these are binary form, zeros and ones. Internally, the system is dividing everything by 2, getting the output 0, 1, 0, 1, 1, 0, 1, 1. Okay. And internally, they will process only these zeros and ones. For 24, what is the value? This is the value of 24. 0, 0, 0, 1, 1, 0, 0, 0. All right. The same thing. Why are discussing about this? Because this is the ultimate thing working on our processor. Okay. And this is where our concept of compilers and interpreters comes. Okay. So finally, what is happening? Assume that this is our code. Assume that this is our code. This code is converted into what? Zeros and ones. These zeros and ones are nothing but these are also called as machine code. Okay. And who will perform this? The processor will perform this. Sorry, execute this. Okay. The machine code will be executed on the processor. So whenever we are writing a code, the compiler will compile the code, the interpreter will interpret the code, and it will convert into the zeros and ones, which is nothing but our machine code. Ultimately, that gets executed on the processor and it will give us outputs. Okay. So this is a little bit story about bit, nibble, and byte. Now there is one more important thing, okay, which is almost your future. Okay. Anybody heard about quantum bits? This is what is your future, guys. Whatever you are learning today, or you might be learning for a couple of more years, ultimately you are going into this particular direction, and that direction is called as quantum computers. Heard about this? Anybody heard about what is quantum computers or what is a quantum bits? Okay, just try to read, guys. Whatever is latest. I already requested you. Okay, just try to read what latest things we are getting in the industry, where we are moving ahead. Our complete future is depend on now the quantum physics. Okay, using which scientists are working on getting us a quantum computers. What is a quantum computer? They are very, very super fast computers. Okay, you can say. So what is the logic or what is the concept on which it is working? Just we'll keep our discussion up to that, because that quantum computer itself is very vast subject. So I just want to discuss only from what we are discussing today, okay, with respect to bits and bytes. So the difference between the traditional computers that we are using today and the future computer, which will be a quantum computer, is what we are using here today in traditional computers. We have something called bits and bytes, right? So there is a possibility of any given number, okay, any given number either to be a 0 or a 1. Okay, I'll repeat. In traditional computers today, whatever they gets processed internally, every data, every character, every information, there is a possibility of only two options. Okay, either they will be converted into 0 or they will converted into a 1 finally. Okay, this part, either they will be converted to 0 or 1, and a combination of those zeros and the ones finally will represent that particular data or number. Okay, in this case, we have taken example as our number 24, right? Guys, listen, this is very, very important. Okay, so this is a traditional computers, what we are using today. Now, if you observe here, at any single point of time, we are using 8 bits completely to represent one number. Same thing now in quantum computers. Okay, so see what magic it is happening actually. What is happening is any number in quantum computers can be either converted to a 0 or 1, or it can be 0 or 1 together. Okay. So that is what is this diagram is depicting. Okay. In the classical computing or the traditional computing that we are using today, any data, any information ultimately will be converted into all binaries of either 0 or 1. 0 is on, 1 is off, the signals. But in quantum computing terminology, there is one more possibility of a bit that can be together as a 0 or a 1 or 0 and 1. Okay. So what exactly that means? What that means? Okay. What is the difference then? Okay. We will see the difference. So this is the difference here. Okay, guys, this is the difference. This is very, very important. Okay. On a lighter note, I'll tell you. Okay. In a war, for example, a army man is having a rifle. Okay. Or some pistol. So ideally, what will be the scenario? If he is fighting, right, or he is shooting, one bullet will be equal to one life, right? One person rather. Just assume. On the lighter note, I'm telling you just to make you understand what is the difference between our traditional computing and the future quantum computing that you are getting. Okay. So ideally, if a real-time army guy, okay, if he is shooting on an enemy, one bullet will kill one person. Okay. Assume that Rajnikant is there. You got my point? Rajnikant is there. He will use one bullet to kill his wish. I'll say 5 persons. In single shot, he will use same bullet to kill 5 persons. But in real time, a real army guy can use only one bullet for one person. That is the practical thing. But if same thing used by Rajnikant, he can kill 5 people in single shot. What that means, Rajnikant is increasing the efficiency of the bullet, right? Same concept here. Okay. The efficiency of the processing has increased. What it means, if you observe here, at any single point of time, all 8 bits are being used to represent just one number. Okay, for number 24 to represent, all 8 bits of the system or processor is used. Okay, but in quantum computing, this is important. 8 qubits. So bits here is called as qubits in quantum computers. Okay, 8 qubits can represent all 256 characters. That means what? The efficiency has increased. The processing capacity has increased. So here 8 bits representing only one number. Here what is this? 2 power 8. This is 2 power 8. That means its efficiency has increased 256 times. So what will be helpful here? It will increase the speed of the processor. It will increase the speed of the processor. This quantum computing can be used for multi-processing systems. That is where all the world is heading towards. Okay, all the world today is heading towards multi-processing. Your AI is completely dependent on multi-processing. And what are helping today for AIs to perform multi-processing? They are something called as GPUs, graphical processing units. Okay, the AI agents basically cannot perform that well on your CPUs. Okay, because graphical processing unit, because CPU's capacity is less and CPUs cannot do parallel processing. Okay, so that is the reason all AI concepts are getting executed on GPUs. What are GPUs? The graphical processing units. Okay, what it does? It has a capacity of doing multitasking. Oh, sorry, not multitasking. It is parallel processing. Okay, parallel processing. What is parallel processing? Different jobs or different tasks are executed at once. Different tasks or different jobs are executed at once. We will discuss in detail when we talk about deep learning. So our deep learning concepts all will be using parallel processing. Okay. Those at that particular point, we will be using our cloud GPUs. I told you, right? We cannot, execute a larger model of deep learning kind of things on our local laptops because our CPUs will not support. Okay. There are possibilities that the system might hang, the code might hang, okay, or the laptop might get heated sometimes as well, because there will be a lot of regressive and iterative processing happens, okay, using something called as neurons, okay, which is concept of deep learning that we will see. But are you getting the idea where we are heading towards? Okay, so these bits and bytes, that's why I wanted to discuss. Traditionally, all the 8 bits are referring to single character today, single data, but future is heading towards quantum computers, which are having qubits, okay, and 8 bits can represent how many characters? 256 characters, which will help us to perform a lot of parallel processing together, which will increase the speed of processing, and we can achieve huge number of larger tasks within few minutes, okay, which will provide less load on our processing systems. But this quantum computing, it will get some time to fully get implemented. And believe me guys, all the big major companies, Microsoft, Google, you just name it, anybody, they're all working on data centers today, which are supporting quantum computers. Anybody heard a huge data center by Microsoft is established in Andhra? Which place it is? Any idea? Heard this news?
Bicycles.
Isaac?
Yeah.
Right. So our great leader Chandrababu Naidu's vision is no, it has fulfilled. Okay, they are getting a great AI data. It is purely a data center. Okay, people might not aware yet. It is purely a AI based data center. Okay, very very powerful data center which are supporting these quantum computers. So it will take some time, probably maybe within 2 or 3 years they all get ready. And this work is happening across world. Okay, the all big companies are working very fastly and very investing very heavily on these data centers. For what? To support AI, which will have internally the implementation of quantum computers. Okay, that is the direction where we are all heading. Okay, there will be no more bits and bytes once these quantum computers get into implementation. That is another story that in Amirpet already there are courses started on quantum computers. I don't know what they are teaching. Okay, but yeah, so this is what is the basic of about the internal the core content, the bits and bytes of our traditional computing as well as the quantum computing. In quantum computing, the bits are called as qubits. Okay, quantum bits. That's it. Yeah, so I think that is enough with respect to quantum computing in our context. So we are happy. Any questions here? You can just type your questions here in the chat. Meanwhile, let's get back to our yesterday's discussion. We will continue. This is a little bit, a technical discussion. Just take this as is. Okay, nothing much to think here. No logic involved. Just take this as is. Okay. go through the reading. Okay, that I'm sharing. You also just read. I'll also try to explain what we are looking into here. Okay, so this is basically called as a Python interpreter. Okay, our title here is internal working of Python. Okay, so this is how internally Python works. Okay, basically we don't care. The intention of keeping this content here is, I told you, right? You are facing agents for your interviews. Okay, and we never know what agent will ask. Okay, it might ask this question also, a basic thing. So just to be aware, what is what. Right. So this is how the look and feel of a internally an interpreter. An interpreter contains a compiler, a bytecode, a virtual machine, and there are a lot of supporting libraries, which are also called as modules. Okay, and this is referring to our source code, the program that we write. So what happens whenever we are writing a code and we try to execute, the code will be sent to internally compiler. The compiler will convert that code into bytecode. That bytecode will be used by the virtual machine in Python, and the code will be executed, and the output will be shown. Whatever supporting libraries are needed, the virtual machine will use them and provide us the output. This flow is as simple as that. Okay, nothing much to think here, but yes, we'll go definition wise and a little bit explanation wise what is needed here. Okay, yeah. So Python is interpreted. Yeah, this is actually the point where I was discussing about that from the interview perspective. Okay, so there you got a question. Python is which kind of a language? The options are compiler and interpreter, and something else. Okay, so Python is basically an interpreter language. Okay, what is that? We will see in few minutes. And it is also an object oriented. Okay, high level programming language. We have seen high level programming language yesterday, right? What is high level programming language? The language which we will write using a plain, simple English, okay, which is human understandable form. When we read it, we'll understand easily what is what. So that is what is high level programming language. Python is also an object oriented language. Yes, we all know what is object oriented language. We have something called as classes. We have something called as functions. We will create objects of the classes. All these things are possible in Python. Okay. One very important statement which I already underlined here is, remember this statement, everything is in Python is treated as an object. Okay. Just take this statement as of now. Remember it. We will revisit this statement when we talk more about these things, the functions, what is a tuple, what is a dictionary, what is a class, and all, right? When we get onto a discussion, we will understand what exactly this means. Okay, everything is in Python is treated as an object, and every object belongs to its class. Okay, so this particular line or point we will discuss in detail when we discuss the actual what is a function. Okay, what are different classes, what is an object, and so on and so forth. Okay, so the main thing is Python is an interpreter language, an interpreter, and a high level language. Then Python uses something called as PVM, Python Virtual Machine, to convert Python code to machine understandable code. Python uses something called as a component, you can say, called as Python Virtual Machine to convert Python code to machine understandable code. So let us see how exactly it is happening. Okay, so to understand this, right, let us understand a couple of things. What is a compiler and what is an interpreter, basically? So there will be generally a lot of confusion happens when you get a question in an interview. Generally we will confuse, okay, when we discuss or think about compilers versus interpreters. Okay, so here is a brief discussion that we will do. This is once for all. Okay, you will have this content with you whenever just you want to revise, just go ahead and revise it. Okay, so compilers, converting source code to machine code before execution. This all we know, okay, because we might have already implemented, C, C++ or Java during our academics, right? So a compiler translates the entire high level source code. So whatever the code we are writing in C or C++, that is a high level source code, right? So this compiler will convert the high level source code to machine code. Into machine code means what I told you, bits and bytes. So ultimately, all the code, all the information, all the data, everything should be converted into these bits and bytes. This is nothing but our machine code. These bits and bytes are nothing but our machine code. They are finally gets executed on the processor. So this compiler, what it does, it will convert all our high level language that we are writing in human understandable form into the machine code. This is important ahead of time. Ahead of time. What that means? Before the program is executed. Before the program is executed. So what compiler does is it will convert the high level language into machine code before execution of the program. It's not like Python. Yesterday, what we have seen Python, we have seen in Python, as soon as we have given the instructions, it started executing, right? Because Python is a interpreter language. Immediately it is giving results. But the languages which are using are depending on compilers, right? What it does, first it has to execute the machine code before executing the actual runtime of the application. What it gives actually, when we say this is converting into machine code, what they will convert into? Basically, they will convert into some kind of executable file, right? When we have executable file, we'll be able to run that particular program. So the first step is compiler will perform this conversion of machine code into exe files. So this produces executable file containing native machine code that the CPU can execute directly, of course, without needing any compiler or source code at the runtime. So internally, what happens? The CPU just take this executive file and it will run the program. It further don't need the actual program or the source code while executing the program. Okay, it will simply use that machine code, which is already converted into zeros and ones in the form of exe. Okay, so this is a little bit of process that actual the compilation how it does in different phases. A compiler uses how it does. Okay, the first part is the first step is lexical analysis. Remember these terms; these are very important. Okay, you have to remember these technical terms as is. Okay, lexical analysis. Lexical is a word specially meant for compilers. Okay, when you hear this word lexical, just remember that there is some reference of compilers. Okay, so lexical analysis. Lexical analysis is nothing but the system, the compiler reads all the source code character by character. Okay, the compiler will read all the source code character by character and it will try to build into some meaningful units called tokens. What is a compiler basically? Exactly what is a compiler? I'm saying compiler, but what is a compiler? We are understanding here what compiler does. Okay. Whatever we are understanding here, we are understanding what exactly compiler does. But what is a compiler? Any idea? Any guesses? Sir, it is nothing special. It's just a program. Okay. Compiler is even a program. Okay, which is written in the low level language. In particular, if I talk, there is something called assembly language. I'm not sure whether you have heard this. All after 2000 guys. Okay, so compilers are nothing but again internally it's a software. It's a program written using assembly language, and there are then certain low level languages. Okay, there are also programs. So what this program is does is this compiler program which will be executed on our program, our code, whatever we have written. And what it does is it will check line by line, character by character. Okay, for example, what I'm saying is I'll say, let's assume we are writing program in C. Okay, I'll say hello. I'll put a semicolon. So what compiler does is, compiler is also a software, a program. Okay, so this whole statement, assume that this is our code. This whole statement will be passed to the compiler program. Okay, so what it does, it will eat our code. Okay, that means it will completely parse our code. Okay, it will take character by character. What is this? What is this? What is this? What is this? Okay, it will take character by character, one by one in a sequence, and it will try to understand it and put it into a meaningful format. Okay, that is what is this first step. Lexical analysis. Lexical analysis is nothing but something related to another the compiler reference. Okay, and they are called as tokens. Okay, the meaningful units that the compiler is reading and converting, right? They are called as tokens. What is the token here? This print is a token. Tokens are nothing but the keywords. Okay, using these keywords, the compiler will try to create this sentence into something meaningful. Whenever a compiler sees that there is a something called print, a token, a keyword, then it will understand that, okay, whatever follows after print is a statement where we have to print the output. Okay. After that, what is the second step? Parsing. Okay, the tokens are checked against the languages, grammars, and rules. So obviously, every language will have its own grammar, right? Its own syntax. So first step is compiler will check what are the tokens in this, whether there is any literals or keywords or not. There is a keyword print. Okay, I understood. There is a print. That means I have to print whatever is followed by the print. But wait, whether this is in correct grammar or not. Okay, grammar is nothing but the syntax of that particular language. Here I am taking example of C. That means what? This keyword print should be followed by a proper syntax, nothing but grammar. That means there should be opening brace. There should be a double quotes. Then whatever you want to print should be between that double quotes. Then that should be closed by a closed parenthesis. Then finally, there should be a semicolon, which will make me understand that this is the end of this particular instruction or line or statement. Got it? So these are the steps. That is what we are discussing here. So first step is scanning. It is scanning, checking all the literals, keywords, everything is present. It is trying to understand and put it in meaningful way internally. Then it is checking the syntax that comes as part of parsing. Okay, what is next? Next is semantic analysis. Semantic analysis is nothing but this point. Okay, it will check how the actual language is implemented. Okay, there should not be any unsupported form of instructions that is not implemented in that particular language. What it means actually, so a string, for example, a string cannot be added with a numeric value. Okay, this is not allowed. So all such kind of things will be verified in this analysis part. So after checking the whole statement, the compiler will also check whether there is any such mistakes in that particular statement. Okay, then intermediate code generation. This is where it will actually convert the code into the intermediate representation. That is nothing but, you can also call it as a lower level of code, the machine code. Okay. Then the IR is optimized for efficiency. So ultimately, it is converting into a machine code. Okay. So this is the one. The optimized IR is translated into a target machine code. So this is ideally the role of a compiler, how it does in a traditional languages like C, C++. Okay. And finally, there will be a linker combined and the file will be executed. Fine. Our interest is in this. Our interest is in this because our Python is a interpreter kind of language. Okay, it is not using the compiler format, it is using the interpreter format. So what is the difference between compiler and interpreter that we will see here? So what is an interpreter? An interpreter executes the source code directly during runtime. What compiler does? compiler, before executing the code, it is creating an exe file kind of thing, okay, a machine code. Then only the code gets executed when they are using compilers. Python is using interpreters. Interpreters, we can directly use code, okay, and it will execute directly during runtime. There is no pre-compiled version of any code. Yesterday we have seen, right? Let me quickly go to a folder. Where are we? Okay. Hope you're seeing my screen. Right. So yesterday we have seen, right? What is this? This is a Python interpreter, correct? So as soon as I'm writing something, rather I should say, okay, this will not, okay, so just simple thing. Okay, just simple thing. I'll execute first. Okay, so this compiler, right? So assume that this is my code, okay, hello world. What is happening as soon as I'm writing, there is no pre-compiled code happening here, okay? It will just execute directly whenever I'm trying to hit this, okay? I'm saying print hello world. Just it is directly executing. There is no pre-compiling, nothing. So internally, what is happening? The interpreter is taking care of this particular instruction. Okay. So what is happening in detail with respect to interpreter, we will see here, right? That is what is directly during runtime, line by line. Okay. So Python do not convert the source code to any native machine code like compilers. So this is the main difference. What is the difference between a compiler and an interpreter? A compiler will convert a predefined code which is called as machine code before execution, okay, whereas interpreters, they will not convert this machine code, okay, they will directly access the code at runtime and provide the output. So how, we will see, okay, they parse the source code. For each statement, they directly perform the corresponding actions by calling pre-written routines in the interpreter itself, which is already compiled to machine code. Okay, that means what? The compiler, sorry, the interpreter will have a lot of inbuilt functions which will be used to perform the machine code kind of compilation and giving the output. The CPUs execute these interpreter machine code which simulates or carries out the source code instructions. Okay, so this discussion we will see here. Okay, this is the actual our Python virtual machine interpreter. Okay, this is how actually our Python code works. Okay, let us understand. So a Python compiler does the same task, okay, but in slightly different manner. It converts the program source code into another code called a bytecode. Okay, if you see the diagram here, right? This is the diagrammatical representation of this statement. So this is our code. Okay, assume that this is our source code, Python code. So as soon as we try to execute the Python code, the compiler, it will convert the code into the bytecode. What is the job of the compiler? Internally, Python is also having a compiler. Okay, but it will work in a different way. It will not work in a traditional way. It is not creating any predefined code before execution. So what it does, this is our code, human understandable form. Okay, it will convert that code into something called as bytecode. Okay, a bytecode is nothing but a machine code again, just at the high level. Okay, it is also kind of a machine code which is understandable by machine. So what is important here in terms of Python is this particular area. Okay, so it is also have something called interpreter. Okay, and this interpreter is also called as Python virtual. a machine. So this is making Python more effective. Okay. And using this Python virtual machine, Python is getting considered as an interpreter, and it is working differently than the traditional compilers. Okay. If you remember, right, this is the first diagram that we have seen. I'm talking about this one in particular. So this small box is elaborated. This small box called interpreter is elaborated here. So this is the architecture internal actually. So what Python source code is doing here, using compiler, it is getting generated into something called as a bytecode. This bytecode will be used by a component called virtual machine. This virtual machine, with the help of all internally library modules. If you are remembering yesterday, I have showed you the documentation page of Python where there are a lot of modules are listed which are already implemented in Python. So this virtual machine will collect the required libraries or modules that need to execute this bytecode to perform action and give the output, okay, as per this source code. So this all internally the interpreter will take care. Okay. Nothing logical here, just understand as it is. The source code with the help of compiler internally converts it into bytecode. Bytecode will be used by something called as virtual machine. In particular, Python virtual machine internally uses libraries and modules and perform the output at runtime. At runtime. There is no predefined code here. It is all live runtime. As soon as you are creating a code or writing a statement, you can directly execute and check. Immediately, Python will perform this task internally. It will convert the code into output ready form. Okay, using something called as interpreter. Okay, and the interpreter has internally a compiler, a bytecode, and a virtual machine. So what exactly they does, we will see more. Okay, I'll take a 30 minutes, 30 seconds pause here. Any questions before we go a little bit depth? Okay, any questions? If I'm fast, just let me know so that I'll slow down myself. The only thing is we have to cover more. So I'm just trying to cover most of the things. Any questions, please? All good. Thank you, Raghu. Okay, so I believe all good. If not, if you are not getting at one time, right, just go through this document again. It is very easy. You can easily get it. Then how Python bytecode works. So what actually this bytecode do? Okay, that we will understand. We understand that as part of the interpreter, as part of this interpreter, Python is using internal compiler as well, converting our code to bytecode, right? So what this bytecode does? Let us understand that. I have clearly mentioned here. When you run or import a .py file, .py file is nothing but our Python code. All our Python code extension will have .py. Okay, all our Python code files will have extension as .py. Okay, that will tell that this is a Python file where we'll write the code. Okay, so when you run or execute a Python file where you have Python code, Python parses the source code and compiles it into bytecode. That is the very first step. That's what we are saying. Okay, so Python compiles the source code and it will convert it into bytecode. So this bytecode is cached in something called as PYC files. Okay, this is again internals. Okay, just understand as it is. Nothing much to think here. Okay, this bytecode is cached in .pyc files inside some directory. Okay, for faster future imports. What it means actually? When we use cache, this term cache we use CACHE. People also call them as cache. Okay, but cache. What is cache? Cache is nothing but temporary memory. Okay, cache is nothing but a temporary memory. When internally a system wants to perform something very quickly, very fastly, it will load all those instructions, okay, respective that to that particular task or module in cache. Okay. So bytecode, this bytecode internally is what is happening is it is getting cached on this particular files. So what it means, we are writing a code. Okay. We are executing it again and again, right? So every time it is a repetitive task for Python to convert it into bytecode, then perform further operation. So what it does, first step is whatever we are writing, when we execute it, it will convert it into bytecode and it will put it in the cache file. This cache file will be under this directory. Okay. Then next, the Python virtual machine, which is also part of the C Python interpreter. The actual name of the interpreter is C Python. Okay, the interpreter name here they are giving is as C Python. Reads and executes the bytecode instructions using a stack-based virtual machine. I think, okay, when we talk about, is this visible? Okay, when we talk about speedy, or rather I should say fast processing, let me type here. Now we are talking few things related to cache. Okay, what is a cache? Cache is a temporary memory. Why it is used for? It is used to perform actions whenever there needs to be a fast processing. Okay, using cache memory, the processing will be very fast. So the format of this cache memory will be in the form of stacks. What is a stack? Anybody? What is a stack? Remember, guys, what is a stack? This is also again a memory stored in sequence. Okay, stored in sequence, right? So all this cache, whatever data is getting stored in temporary memory, will be in a form of a stack. Okay, you can assume stack as a row by row definition of the data. Okay, so what this PVM does is, whenever it is trying to execute the code, it will pick up the data or the machine code from this cache and it will execute it. Okay, that's what this statement is saying. The PVM, the Python virtual machine, reads and executes the bytecode instructions using a stack-based virtual machine. So what is a bytecode and what is machine code here? The same thing we are defining here. Okay, but what is important here is how this is actually working. Okay, again, the same diagram. So a couple of important things. One is, see, only 3 steps here. One is source code with the help of compiler is getting into bytecode. This bytecode is stored in a temporary memory for fast processing. Whenever this code gets executed, this virtual machine uses something called as a stack, which is nothing but your cache memory. Pull all the information from the cache. With the help of certain inbuilt modules, it will try to do the output of the programming or the code. Simple. That is the basic step that you need to understand. That is the flow. Okay. What is important here is Python is a interpreter language. Python is a interpreter language, not a compiler. Because as part of interpreter, you have something called as compiler, bytecode, and virtual machine that will be used by Python. And while executing your code, they will use this internal architecture. Simple. Okay. Got this? So these three things will happen when you execute a code. First is it will be converted into a bytecode. Then it will be stored in a cache in so and so folder, something called as PyCache. And the PVM, the Python virtual machine, will execute that code, pulling it from the stack-based virtual machine or from the memory. Okay. Now let us see. We'll take an example. What we'll do, we'll quickly take an example and we'll try to see what we have discussed. Okay. What I do, I'll just try to, let me go here where I'm here, code. Okay. Yeah, what I'll do, I'll just create a new file with a sample code. Okay. So our code name is, the extension of Python file is .py. Okay. What happened? It is converting. Okay, let me do this. Let us see whatever we have discussed, right? About, the compiler, interpreter, what is a Python virtual machine and all that we will see. Okay. Um, what I will do, I'll on a notepad, I'll put this code. Let us try to understand what is happening. Okay. So demo.py. Right. So we got file called demo.py here. Okay. Now let us look into the document. So what I'll do, I'll show you how exactly, this bytecode looks like. Okay. So this is a command. This command runs Python's built-in disassembler. DIS refers to disassembler module. Okay. The bytecode at disassembler on a specified Python source file. So let us see. Okay. So what I'll do first, I will execute this. So what is the file name? Demo.py. See, we got the output, right? Let me rerun it. I'll clear. Everybody seeing my screen, right? Hope I believe you are seeing my screen. So my this sample program contains, okay, one print statement. Let us see the bytecode of this program, which is nothing but a string. Then as I'm assigning some values to A, B, I am performing some print statements. Then I'm trying to add those two values and putting it in a third value. Okay, third variable. Then I'm printing the third value. This is a simple Python code. Okay, what we are trying to understand here is we are writing the Python code. Internally, how exactly this code gets executed. We spoke in terms of bytecode, right? We spoke in terms of compiler, bytecode, Python virtual machine. We will see what all things are happening internally, how we can exactly look into those internals, right? Okay, so let me save this file. We got the result, right? A equal to 10, B equal to 20. So shall I do something here? Okay, some C equal to 30. This is something meaningful. Now this is our code. Okay, we executed our source code. We are happy. We are looking into our output. Out of 100 times, we are interested 100 times just to look into our output only. Okay, we are not seeing all the rest of the things what you are seeing now in a couple of minutes because we are not interested. Just for idea sake, we are looking into those things. Now what I am doing is I'll use this command and I'll give the file name. What it gives is, are you seeing this? What this command gives? Okay, it compiles the code to Python bytecode. Okay, we have executed the command. Okay, we have executed our Python file demo.py. So it converted into the bytecode. Okay, then the disassembler. Okay, this is a module or a function internally. What it does is it the disassembles that bytecode, printing a human readable listing of low level instructions. This is actually the Python interpreter that will execute. Okay, see, this is how actually our bytecode will get converted. These are the internals of how exactly the Python programming looks like. Okay, so don't bother about the left side things. just try to read. These are all, uh, these are particularly called as assembly language. That's what I was referring to. Okay. But just try to understand here what is happening. Okay. So this is how internally our code gets converted. You see, the first step, load. This statement got loaded. I told you, right, in this example. If you see this, I have given this. While explaining compiler, I told you, right? Step by step, compiler will read and understand. Same thing interpreter is also doing. Okay, what it does, it is loading all our instructions. So first load name, print. By looking at this print, the interpreter understands that, oh, this is the keyword of Python. Okay, so this has special meaning. Okay, loaded. What next? Then load the constant. Okay, then whatever we are giving followed by that print, that got loaded. Similarly, all the variables, whatever we are using. Then again, print statement we are given. Then again, next statement, next statement. All these one by one, all this code, right? Whatever we have written, is all codes get dissected and it is converted into a low language program like this. Actually, this is the output of the bytecode. Okay, bytecode generally we cannot see. It is in a machine understandable form. But using this command, this disassembler, what we are trying to understand is how exactly the bytecode, what contains the bytecode. These are the instructions contains in the bytecode. This is how all our coding will be converted internally to help machine understand and execute our task. Got it? Any questions here? We are just trying to understand internally how our Python code is working. Okay, which is not for our interest, but just for information sake. Okay, right. So this is all explanation about this, the disassembler, how we can look actually the content of the bytecode. You might expect a question in the interview. We never know. Okay, what is the importance of bytecode? Or can we see bytecode information? So you can just refer this. Yes, we can see the information of the bytecode by using a disassembler. There is a command using which it will just do reverse engineering and it will print the output of our code. Okay. Right. Then one more final thing for today. This is all done. Yeah. We were talking about .pyc files, right? If you observe here, Python virtual machine will cache our code, okay, the output in a .pyc files. So any PYC files created here? Let me check quickly because no. So this is our file, right? Let me put it in the top. This is our Python code, okay? And when we executed this code, we have seen there is an internally bytecode got created. We used disassembler command. We have reverse engineering the bytecode and saw exactly how our code is getting written or converted into the bytecode. Now we will quickly check final thing. Okay, we are theoretically we are saying that okay, this bytecode is cached in .pyc files inside this directory. Is it possible? Can we see? Let us quickly check. Yes, we can see. Okay, we can see what we'll do. We'll just execute this quick command. What we are doing is we are manually compiling it. Okay, let me do that. Our file name is what? Demo.py. Okay, now if I type dir, see here the difference. Earlier we have only our Python file. But when I wanted to see the compiled version, what exactly it is, we got something called underscore py cache. Guys, are you observing here? This is the difference. So this is what I was referring here, okay, about this flow, this flow. So internally, our source code is compiled and converted into bytecode. This bytecode we have seen. We have used a disassembler and we have seen this. Okay. But what exactly is the cached value where it is stored? This is the folder where it is stored. So this folder contains our cached value of source code, which will help us. Shall we go inside this? Which will help Python to execute our code fastly. Okay, you see here, there is something called as .pyc. What is it? .pyc? Python compiler. Got it? This we cannot see. This is machine level kind of file. Okay, we cannot open or we cannot see. It will be all junk for us. But just for understanding sake, okay, so what is happening when we are writing a code, internally that code will be compiled and converted into bytecode. At the same time, that code will be cached in a folder called py cache. Inside that, that code metadata, or you can say the machine level code will be stored, which will help Python to process our code very fastly. That is why the Python is an interpreter language which will give output immediately because of this cached information. Okay, because of this cached information, because of this bytecode which is being used by Python virtual machine. Okay, this is all just for information sake. You can just have it. Okay, what I'll do, I'll give snapshot of this. I'll put it in our document. Yeah. I'll put it at the end so that this not gets disturbed. Clear? What will your title here? Python interpreter flow. Okay. Right. So guys, these are what is internal of how exactly a Python code works, just for our understanding sake. Okay. Nothing important, but important while you attend any interview. We never know. Okay. Anything can be asked. We should aware of what is happening internally when we are using that language. Okay. Python is basically an interpreter language. And we also covered, what is bit, byte, very basic things. What is the nibble? And we also discussed about your future, how the future processings are happening using quantum computers. This is again a very important topic. Okay. Whenever we'll get time, I will give more, information how exactly quantum computers are working and what R&D is happening in that area. Right. So any questions, sir? Anything? Any question?
Kunal. Basically, when you look at the other languages,
Mm,
so we are defining the variable name. Suppose if it is an integer, we will be defining as an int and we're giving that
correct.
variable name. And
Correct.
if it is a string, means we'll be giving string and something very given. But
Right.
when it comes to Python, we are not declaring anything directly. We are giving the variables. It's internally it is checking it is a integer string.
Correct. Correct.
How it is impact the like performance? I suppose everything it checks at the runtime only, right? So how the performance comparatively other language?
Right. Very good question. So this is where you are seeing there this library modules.
Yeah. Yes.
This is a section where, okay, so that is the first reason yesterday I showed you our that document. Okay, the library page of our Python document. Okay, so that is the place. Very good question. Okay, very nice. So this box you are seeing here, right? The library modules. So
Mhm.
these are nothing but the Python libraries. When we install Python, right? Yesterday I have installed Python. Lots and lots of libraries and inbuilt modules will be installed on our machine. Okay. So, so whatever you are asking the question, right? So these modules will take care. The Python is intelligent enough. Okay. It will check without defining int whether this integer or not. How? Internally, there are inbuilt modules which will do that job for you. Got it? So that is where is this library modules are connected. These library models are nothing but all the Python modules, all the Python libraries.
Right.
So instead of we manually giving int, like in traditional language, I told you, right? That is the beauty of Python. So most of the things which are required by us, okay, which we have to implement in traditional learning, is already implemented as part of libraries. So internally, all the things will be taken care by the Python libraries. So if you are declaring something like this without any int and all, Python will using those inbuilt libraries, it will check. Okay, it has its predefined function. If something is written like this, consider it as a numeric. Okay, just I will change this. Observe here very clearly. Okay, suppose I am giving it in double quotes. I am highlighting here. Okay, earlier it was without double quotes. So Python is intelligent enough. It has its own pre-built modules. Okay, what it does is whenever it see this instruction, internally your module gets executed to perform this. Hey, whether this int or float or string. Okay, when Python sees that a equal to 10, it will automatically consider integer. So internally, inbuilt module will take care of that. We no need to mention int. Suppose, but it is our job. Okay, suppose I am writing like this, then Python will consider this as a string. Okay, it is how the Python is interpreting this statement. Okay, so depending on its interpretation, whatever we are passing, it will be automatically read and processed using the libraries. That is what is this library reference here in this structure. Okay, so that is the reason.
Sir, can
Yeah,
we declare the type of that variable?
int here.
Like int a is equal to 10 like that?
No, there is no int in Python.
Yes, int a is
Okay,
equal to 10 like that.
yeah.
Okay, fine.
So tomorrow our class will be depend on this. Okay, there are something called as literals. Literals are nothing but the keywords.
Yes.
Those we can use in Python. Okay, along with the variables. Yeah, variables we all know, right? Whatever we are seeing here, right? Declaring values into something. Those are variables. Okay, so Python uses a lot of internal libraries which will automatically take care of whether it is a int type or string type, or a constant or something like that. The way how we are giving is important. So depending on what we are giving, Python will understand. If I'm giving a is equal to 10, it is a number. When I say a equal to double quotes 10, it is a integer. As simple as that. Clear, Ramakrishna? So Python is having a lot of inbuilt libraries. It will automatically take care of those. No need to declare in specific. But yeah, it is our job how we are giving the instruction. Correct? We are responsible, right? How we have to instruct. So that we have to be careful. If you want to give integer and if you are giving in double quotes, that means it is your mistake. Internally, Python will consider this as a string. But otherwise, yeah, no need to explicitly mention that. Clear? Good. Right. So tomorrow, yeah, tomorrow we will start with our discussion with the same thing. Okay, we will start understanding what are literals, what are keywords, what is a variable, all other details in Python. Slowly we are starting, towards coding. Okay, so guys, just make sure, again requesting you all, just get enroll yourself quickly so that we'll shift this. First we'll shift this URL. Okay, we'll just change this WebEx link. We'll go, sorry, this Zoom link and go to the actual classroom. Then we will have a clear discussion, and I'll keep all the notes whatever we have discussed till now. Okay, so that you'll download and you can practice. Okay, if anything is not there, then we will wind up. Yep, thank you all, thank you Abhiraj. Have a good day. Let's see you tomorrow. Okay, all the best. Bye.
Thank you, sir. Bye.
Yep.